respected Dr. Anil Kumar sir and dear students, I need not repeat once again, but it is a matter of happiness to say something because I would say Sir University is fortunate enough to be incorporated into the scheme just by I would say the support from university. Uh, just to begin, but hereby representing their universities, I was thanks to Sir and the whole community of university. And I think we were there quite a number of times, maybe as a group, maybe individuals. Every time we used to get a very good support. All kinds of extensions from the University of Hyderabad, which is beyond the limit of expectation. So that also we and hope this will continue, and we are sure that this scheme will improve our academic status. So we are looking forward to recovering our So yesterday we had this inauguration function. Yesterday we inaugurated this facility, and we cannot see this kind of facility elsewhere even in engineering. So being motivated by the support University of Hyderabad through the ANR scheme, for the first time we are having this kind of an arrangement where this is a very good platform for convergence. So we asked students and faculty from various departments, science departments, so very thankful for the also part of that. And here, on behalf of director, PI Dr. Theragnostic, Biosciences, I welcome you to this university. And you all know how specific our project is. Unique convergence. We used to speak about interdisciplinary, multidisciplinary convergence, but here you have a project where absolute convergence is there in different areas of great science. So these are our scholars associated with. So we expect more from this. So your contributions are going to be there ultimately to move the end. And see, Dr. Anil Kumar sir is now working as an assistant. You are my teachers, you are alumni. No need of introduction. No, please. No, I little shy. No, sir. I have to spell down your academic significance. That is because I will focus only on academic matters. For decent agreements, please. So we have Dr. Anil Kumar from University of Hyderabad. I would say in the beginning, most ideal person, one of the most ideal person from University of Hyderabad. Who can be involved in our project, fully interdisciplinary research approaches. Sir has been working, as you can see, working on metabolic diseases and molecular biology. And we all know how molecular biology has transformed the entire life science. Actually, we have now started looking entire life sciences, I would say, in a language of chemistry. Right. So that's molecular biology. You take any subject, agriculture, veterinary science, botany, zoology, biochemistry, microbiology. So molecular biology has transformed all these subjects. How we have started reading the concept of biology in the language of chemistry. So sir is different to that approach. He has been working in the area of metabolic diseases through molecular biology. So that is his area, and diabetic nephropathy, and then chronic kidney diseases. These are specific areas on which Sir is now focusing. And he has also made remarkable contributions in the aspect of bioinformatics. That's what I said. One side you have metabolic diseases, on the other side you have molecular biology, and now you can see Sir contributing traveling to bioinformatics and then on communication. So, ideal resource person for our project. So we are very fortunate to have you, so I request you to kindly deliver the so I
எல்லாருக்கும் வந்தனம். Thank you for the also Dr. Chandana for having me here. Wonderful, madam. Uh, Actually, I always feel emotional when I'm talking to especially younger students and scholars because you people are our asset of the country. Okay, as an old man, I can't work on a bench. I don't have energy like you people. Uh, there is saying that Barokkar are the middle. So we all try to give something for the young people. So you people have to take the baton. You are the future of this MGU, future of this Kerala, future of this country. With the gratitude of being able to, I was invited by our ANRF management here. I'll cover next. Be relaxed, very casual, very informal. Okay, just if you want to get a coffee or water, feel. But next 30 40 minutes, I'll explain about Uruchiru Katha. Okay, Uruchiru Katha about Jiva Kosha. Okay, so uh, I always have a I wanted to not exaggerate. I begin with thanking the Kerala because the finest teachers in my life are from Kerala. I have a Shishikala Nair, my biology teacher from Namaste sir, Vandanam. Shishikala Nair who taught me the biology when I was in 9th and 10th grade. In Chhattisgarh, I was from Chhattisgarh. Mr. Majbudesh, Chhattisgarh, Shishikala Nair. Then the same time, my there is Jita Nair, my English teacher. Sorry, Jita Nair is my physics teacher. Suchita Madam is the English teacher. Then I moved to Andhra Pradesh. There we have two people. Oh, sorry. Sorry. So this Cherry and John actually from this place, and Sabushruti from this place. So you can see I'm not just making it, but I'm telling the people, the powerful people in my life, the most important people in my life are from Kerala. I'm having gratitude to my professor, my mentor, Professor Ram Menon, with whom I learned about the diabetic nephropathy. Professor Menon is actually from Kochi, Professor Menon and his wife Rajeshri also. So I have high gratitude for this land of Kerala, and especially today in my lab there are two students are from Kerala. One girl, Srilakshmi Santosh, and another Hadia. So both are from this place. So this is the auspicious thing. It's it's land of God's own country. You could see this beautiful building. Some of you know it. This is a very vast building of. It comprises 69 faculty. So we bombard each other. We learn from our colleagues extremely because when you have powerful colleagues, like you know that we learn from each other. Right? Sense, okay. Uh, oh, you have to move on. Okay. Yeah. So this art is by Kidney artist one of the PhD student. Okay. So what I want to tell you about, I told you no, okay, one chill story about Jivakosh. Okay. We all so many millions of cells in our body. These cells experiences high glucose, right? I'll tell why you have to sit in this classroom for next 30 minutes. Okay. I'll tell you about learning of it. Next page, please. Next slide. Yeah. So we're talking about very what you know about kidney structure, aspects of the kidney, and in very few slides, one or two slides, I talk about how hormones deregulate in diabetes. Of course, we already know about insulin, but anyhow, insulin won't be there, right? In the diabetes, a type 1 or type 2, there will be no insulin, right? So when insulin is not there, what happens to our body? What suppose for example, when your father is not at home, you try to make more noise, right? When parents are at home, you try to be less noise. Okay, let's see what is the noise in the body, hormone. Then I'm talking about the developmental biology versus the disease. See, we develop from a small, tiny cell, one cell, fusion of the gametes. This one cell becomes two, two become four, four become eight, 16, keep on going. The developmental stage, whatever transcription factors are very active, when you become the baby boy or baby girl, these transcription factors expression will be very low, right? Very high transcription factors expression, very low expression. But in disease again, high expression. Let's see how the high, low, and high. I'll talk about that one. Then we talk about the use of the fly model. See, always we cannot use human beings, epidemiological studies, so we will be doing that. Okay, next slide, please. You can stop me anytime if you have doubts. Okay. I told you about right Chiru Kata. Okay. You know this story, the character in our Ramayana, right? You know that this guy, very powerful man. He's very efficient. He sleeps significant amount of time. You poke this guy, he can't discriminate between friend and foe, right? He won't discriminate between enemy and friend, right? This guy. Okay? You know the character. Huh? You know that, right? Kumbhakarna, right? So many cells in our body are just like that. For example, the organs which are affected by diabetes, for example, you have retina, right? The retina, the pericytes are there. Neurons also these cells. Pericytes, neurons, podocytes in the kidney, all are these kind of cells. What do you mean by sleeping giants? It's sleeping giant, right? What do you mean by sleeping giant? There is a respiration, there is a metabolism happening, but they're not walking like us, right? They're not running like us. So cells in our body are they're terminally differentiated cells. What did I say? Terminally differentiated. They're terminally differentiated cells. So these cells are just silent giants, but this you cannot poke them. If you poke them, they'll become weird. Okay. So I'm trying to take you from a simple epidemiological observation to the very epicenter of the diseases, like very molecular level. Okay, from the observation to molecular level. Okay, then we'll talk about therapeutic possibilities. Next slide, please. Okay, so can you press this one on the screen? Okay, you see this guy. The big cell is dead, right? Okay, and when it becoming endangered, when it is disappearing from the system, a big cell podocyte in the kidney, it is undergoing a cell death and is trying to form a kind of tubes with the neighboring cells. Okay, this is cell death. Seeing is believing, right? A small book. Okay, so we talk about why these cells will die. Okay, and why we get a proteinuria, why kidney is failed. Okay, so this was the remember this one. You should get the answer from me why these cells undergo death. Okay, that's the ultimate learning objective from the class. Is that we will be able to know why these cells are there. The story is same with the number of retina, neurons, and podocytes because diabetes is very complex and very debilitating. The fact is that next slide, please. This is the what I want to show. Yeah, this is a very debilitating fact. This bothers me a lot, especially the southern states of India contribute for a lot of GDP for the government of India. So the money what you people pay taxes in these southern states, they go to the center. Center spends a lot of money on the underdeveloped like Bihar or UP some places. But the problem with you see the darkest color is there for three states: Kerala, Tamil Nadu, Andhra Pradesh, and West Bengal. You see, so you see the political equality of the Kerala and West Bengal, and also the incidence of the diabetes. The most debilitating factor we are on the granite mine, especially the three southern states. Very high incidence. You see the percentage of incidence diabetes, 27% the Kerala, 27%. Like out of 100 people, 27 people are diagnosed with the hyperglycemia. Dear scholars, don't get offended. Raise your hands if any one patient from your home have a diabetic complication. Raise your hands. We have, yeah, obviously we have 30% here. That means it's true the number. So why is happening so? Why? See, in the recent past only the last 30. You see, unless we careful from next 30 years, this number will pop up more, right? So the state of Kerala. Remember, is a part of NRP or being scholars of the Biosciences department or Biological Sciences department. Your fundamental job is you should be fit. You should be fit. You should not get into the diabetes. I mean, if you, because for example, genetic history is there. See, my mother and my mother's father also diabetic. So obviously, genetic factor is there. But you can overcome a genetic factor by thorough awareness, right? Your fundamental, be a good example for the society. Be a good example. So what you do? Just careful about your diet, careful about your exercise, careful about your walking, careful about your dietary habits. Okay. So late night dinners, because don't eat the mode of the glucose pumping diet, low glycemic foods you try to eat it, and eat more kind of the very, very ancestral foods like which you, a food which your father never knew, which your grandmother never knew, don't eat. Okay, the more automation of southern states, more amount of infiltration of the western foods, these are two culprits. I want to tell you something. We tend to eat more biryanis. What biryanis were there 100 years ago in this land of the Kerala? No, we don't have it there. They are fried foods. They stay longer time. They continue. And was there any kind of dinners were there in our culture? Why we tend to eat late nights? Because you need to have 14 hours fasting for the body. 7 hours your grandparents used to eat. 7 to 7, 12 hours, and again 4 hours. We are always trying to eat. So the 44 hours. Am I going to show one slide for you? This is true slide. What I did the research in my lab. Okay. See, I always work on what is the natural thing, translate it to the bench level. Okay. Please remember, Kerala should, of course, Andhra Pradesh, of course, Tamil Nadu. The fundamental thing in always should be in our mind is that this future. See what happens. I will tell you complicated. Men are what men become important if they have diabetes. Life life gone. Like the future generation of the Kerala or Andhra Pradesh or Tamil Nadu will have a problem for that. Okay, that's fundamental thing. Okay, health is the number of priority. Next slide, please. Okay, yeah, you know these complications. I need not tell you about the outcome. Okay, next slide, please. Okay, so this particular slide is always there in your textbooks, right? Up to you have kidney, then you have nephron, and nephron has a glomerulus and tubule. Next slide, please. This, okay, imagine this is the blood vessel, okay? This is the blood vessel, okay? Blood vessel like that. This blood vessel goes to the glomerulus, means the take a lot of blood vessels like here. These are the blood vessels, okay? They are there, okay? They are there in the glomerulus. Now you see my fingers, huh? You see my fingers, huh? My hand, my palm is a cell, okay? This my palm is a cell. See the cell is covered the cells are covered the glomeruli, right? Yes or no? You see tightly covered. So this is a blood. Okay, blood has this small solid like water molecule. What do you call your urea, creatinine, and pigments and all. They can filter through easily the water, excess water, and small filter through my fingers, right? Imagine this cell have a finger-like projections, food process. Imagine, you see the observation, my gap between fingers has become big, right? Now if they become big, the proteins, antibodies in the blood, they go in the urine. They filter out and go in the urine. So our kidney should be like this. Our glomerulus should be like this. Very tight, very small gaps. Unfortunately, in people with diabetes, the gaps are big. The proteins are coming. That's why you could see proteins in the urine. What happens to protein go in the urine? What are these proteins? Our hemoglobin, globin proteins, our antibodies, important immunoglobulins, all things are going. And liver has a problem. Why liver has a problem? If the blood becomes thin, water in the blood comes to interstitial places. To retain the water in the blood, you need proteins. This is called oncotic pressure. Very basic, oncotic pressure. You know osmolarity and oncotic pressure. Whenever proteins or high molecules goes out of the blood into the urine, liver has to secrete lot of proteins. That it, liver sensitive, and more load on the liver. When the liver proteins, actually when less proteins are there in the body, if the thick solution, heart can pump like this. If a solution become thin, heart has to put more pressure, hypertension. See the logic? Kidney failure leads to liver failure, leads to hypertension, heart failure. From multiple pathologies. Okay, every organ is important, especially organs crossed up in our body. Next, you see, okay, hold on, please. You could see this one. This is our blood vessel. Around the blood vessel, big cell, holding like it's like holding like this, okay? Holding like this, okay? This blood vessel holding. You have finger like projections, okay? They are good process. This image is taken at TEM facility of CCM in Hyderabad. Of course, we also have TEM, but our TEM was not giving high magnitude. It was taken at CCM. So we took this picture, not for. This whole picture was drawn by scholars like you in my laboratory. Next slide, please. Now, I took you people to deep dive into the kidney architecture. So, what is the function of this podocyte? They acting like funnel, right? And they also oppose hydrostatic pressure. And when you are filtering something now in the tea filtration, you need strainer, right? You need strainer. What the strainer is that the rim of iron is doing, it is opposing the hydrostatic pressure. This is not strong enough. When you pour the tea, they all pop up, right? That is very strong. So this podocyte is providing three functions: filtration, oppose the hydrostatic pressure. Third thing, size selectivity. Selectivity. It only able to remove the small molecules and urea. Okay, healthy. When we become sicker, the gap is formed. Okay, next slide, please. Okay, this is we draw this just to educate people. Healthy cell, very good, right? Blood has more proteins. Sometimes cells become hypertrophied. Okay, this is a sleeping giant like Kumbhakarna. It become hypertrophied. What you could see that slow, all contents are getting multiplied and the nucleus is also becoming bigger. Sometimes they undergo apoptosis. Sometimes they become cell death or they become detached. They detach in urine. So this is what I want to tell you. Many cells in our body they adhere. Unfortunately, some cells will detach in the urine and come out of the body. Podocytes also appear in the urine in some patients. And then these podocytes is becoming like inflammatory cell. This is another problem for us. So diabetic nephropathy is also inflammatory component. Inflammation. It attracts more macrophages from circulation. So this is the problem. Next slide, please. Okay. So I told you now so far you know the little deep diving of architecture of the kidney, right? Whatever textbooks we study from the textbooks up to kidney glomerulus. Now I took you to the another level of the complexity, podocytes. Okay, glomerular podocytes. So now I want to tell about something. This development. And majority of the diagrams what I show you drawn by my PhD scholars. Okay, I did little bit of improvement. So this is a small bud when we are at 32 cell stage in mother's womb. Organs are forming right slowly. It is actually ureteric bud. Kidney will start to form so like small bud. It has a bud and some mesenchymal cells. These mesenchymal cells they migrate and try to become epithelial cells. You see, it is a look at this one. It is a comma shape. It is a another bigger comma shape. It is S shape. So like that you are getting a globe and nephron. Now, this is the different stage of the nephron. Very crucial stage of the nephrogenesis. What do you call nephrogenesis? Some cross-section factors are very crucial. WT1, zinc finger epox binding, JEB2 are not. They're very crucial. They give the fate development. So I want to ask a question. In 2002, American and government through their NIH, the highest funding body, they did sequencing of human genome. Right? Is there any use for the sequencing of genome for the diseases, cure of any diseases? They thought that if you know the sequence of genome, you can cure many things. Why insulin only produced in pancreatic beta cells? Why some cells behave like neurons, not any cells behave like neurons? So how you identify your own home? Your home and next home maybe look like same. Your home and your home, your what do you call your father's brother's home or your father's sister's home almost look same if at all maybe. Then how can we go selectively to our home? What I mean to say here, the cells differ, organs are different from each other by a transcription factors what they express. That is one crucial thing about the nature. Transcription factors are that determine the fate of a organ. Fate of the organ is determined by transcription factors. Pancreatic beta cells produce insulin only on influence of transcription factor that drives the insulin secretion. Same way, you have pituitary gland, right? Anterior pituitary, they only have a lot of hormones to secrete. Because this hypophyseal axis secretes one kind of transcription factor. Under influence of that transcription factors, these are genes will express. So transcription factors are very crucial. Okay, that is why human genome project is absolute failure. We thought we can sequence. It is not a Cells, remember beta, we evolved from 4 trillion years ago. Keep evolving. We are in a small landscape. So when we're evolving, our organs are decided what are unique function. We don't know how they got the rhythm, how they remember it. Even molecules all have memory. So our cells try to produce unique transfer factors under which several are under control of that. Okay, got the point? So transfer are very crucial. So if the transcription factors are there, then organ fulfillment will be done, organ function. Next slide, please. Okay, now what I want to tell you that this is the development of the glomerulus, right? Nephrogenesis, nephron. So this is called differentiation happening. So differentiation begins here, differentiation ends here. But some transcript factors, they are more at the initial stage, and as differentiation moves on further, their expression is very less. So look at beta, not shown expression is very high, becoming low further low. Notch is transcript factors. Okay, Notch is a name given because it's observed in the first flight Drosophila. I will come later. That's expression. So as we becoming kids in a mother's womb, in initial stage, a lot of transcript factor overexpressed. As we becoming a baby, the expression is very bare minimal, very basal. Got the point? Very basic. Okay, remember this one. Next, please. Okay, this is one thing I want to tell you. This is the cell cycle. After every cell cycle, cells holds for some time at G0, right? G0. If at all cell want to multiply, then it becomes G1, then G2, S, and mitotic phase. Okay, that's how they undergo. These podocytes are neurons or pericytes. Remember, beta. Neuropathy, nephropathy, retinopathy. What happens in these stages? Cells, these are all critical cells, they stuck at G0, they don't divide further. That is why neurons, if you have damage to neurons, you cannot get the new neuron. Right, yes or no? Neurons get damaged, neurons stay. So cells are at G0. What we call at G0 cells? Quiescent. What we call? Quiescent cells. G0 stuck at quiescent. So many years scientists know that these cells are terribly differentiated. When damage occurs, we don't get the cells back. So what some intelligent scientists are doing, they try to do the pluripotency. They want to bring the pluripotency in them. Like they want to make the cells ancient cells. So they divide and they cure. The number will grow. Suppose, for example, the cells are detached. Now I will induce a pluripotency in them, so they produce these cells. That's what we're trying it. One branch of scientists are trying to do stem cell therapy. This is the stem cell therapy, right? We're trying to do it. We take the cells from the our vertebra, our bone marrow. We're trying to do it. It is successful in fused like liver and liver. Gastroenterology is very successful. Okay, even like big hospital, like for example, there is a hospital near to our university called Asian Institute of Technology. They do it. Take the vertebra, put the Yamanaka factors. That's who did this one. Who induced the pluripotency, make it happen. This one happened. But when we thought that cells are not dividing, they're dying. That's what we thought. Still the neurons not yet completed. Only the liver and successfully intestine, people are doing it. So podocytes are very deep, right? Very, very deep. Kidney, nephron, globe, and podocytes. We're trying to understand what happened to these podocytes, why they're dying. That's what our concept. Based upon the existing knowledge, these cells are quiescent, they're in G0 state. Next, Peter. Okay, now we wanted to take one model system graph. We want to study something about this. I want to correlate model system. Like first time I thought about what are the ecological factors. Kids, glucose, you know that hyperglycemia is there in diabetic people. And also there are AGs. You know what are AGs? Advanced glycation end products. Um, um, uh, uh, you people have ever saw when you boil the milk by mistake, your mom forget to boil the mistakes. Milk turns which color? When you keep boiling, milk becomes which color? Okay, keep it aside. You know the chicken, when before you are going for when you bought the chicken from the market, it looks very pale color, right? Pale white. But when you cook it for some time in a microwave, or when you go to the restaurant, KFC, what is chicken color in KFC? Don't tell it you never been. Huh? It's a brownish, right? Milk color, okay, of course, girls, every girl will eat chocolates, right? You people eat chocolates. What is the color of chocolate, milky chocolates, what you eat? What is the color of chocolates? What you eat? Five-star chocolate. What is the color? Huh? Brown color. Where you get this brown color? Let's see the. After some time, I'll show you one slide how this brown color is so dangerous. Then you have fatty acids. Then you have the growth hormone TGF-beta. Alright, growth hormone is a hormone of his endocrinology. TGF-beta is a downstream cytokine. I work on all of them. Okay, but I, because since you are students and I don't want to bore you, I'll talk about very decent story about age, whatever growth hormone, little bit about AGs and fatty acids. Okay, I'll talk about this one. So, what is the major challenge in biology is that how hormones intricate relationship of the hormones. For example, aldosterone is there. Aldosterone, excess aldosterone is not good. Excess thyroid is not good. Low thyroid is not good. Excess insulin is not good. Low insulin is not good. What is excess insulin? Hyperinsulinemia, right? Excess is not good. Next slide, please. Okay. You have a low insulin, portal means circulated insulin. Very low insulin is diabetes, right? You have a, just don't worry about this one. I wrote a very good chapters and all. Just I want to tell you one thing. Next slide, better. Whenever you have excess, when you have low insulin, growth hormone hypersecretion will be there. That's the point. Growth hormone, believe in that. Mechanism is simple. When low insulin is there, actually, I told you right, mom and dad are insulin and we are growth hormone. When mom and home at home, we are very basic. We don't make noise. When they are not there, we make noise. Naturally, right? Everybody make noise. So now, you just listen this story, very good story. Whenever, for example, when I was 16 years old or 17, 18, I crossed puberty, right? So all of us at the age of puberty, we grow. Like we are like baby crawling. Then we grow. This much height we grow. After that, we don't grow further, right? Because these bones plates are attached. There is no space between the bones. So this skeletal growth is called somatic growth. Around puberty, like suppose we cross the puberty, we get the puberty at 14, 15, 16, 17, whatever the age, 12 to 14, 15, 16. That is the age we stop growth. Our bone growth will start. After that, we try to become little bit of weight organ size. So growth hormone's role is completed to support the skeletal growth. We don't grow further, right? Height wise. Okay? Yes or no? So then what is the role of growth hormone across the lifetime? It has hardly any role. Yes or no? In bone growth, in somatic. Why we are calling it growth hormone? Okay. You are following me? Very interesting fact. Growth hormone role, if at all it is there to promote the growth. Our growth is stopped, right? Skeletal growth is stopped. If I don't have growth hormone, I will be dwarf. Yes or no? Dwarf. If I have more growth hormone, by age of puberty, I will grow like a gigantism, like 7 feet, 6.5. Like, so, growth hormone's role, if you really grow, I am repeating for you. If growth hormone, just forget about the name. If the growth hormone, it promotes the growth, that's somatic growth. If the only role is growth hormone's role is growth, what is its role after puberty? So, when we discover any hormones, we call them as an observation. But later on, we do lot of new properties for them. Alright, if you want to read it, suppose you are Christian or Hindu, or you are Islam, what we study, very old books we study, like Islam study, Quran, it's like 700 years, 1000 years old Bible, or like Bhagavad Gita, like Bhagavad Puranas, another 4 or 5,000 years. Okay, in religion, we study old books. You want to study in science, what you study? Recent discovery, last month discovery. And I don't know, it's yet to publish it. Bioarchives, we study. So science law, new things. Science, literature, old things. We will follow, right? Okay? Because why we follow old one? So we don't see that they're mixing with other culture, mixing with other samskrutis. Okay? See, how slowly the Malayalam language is just fused with English words. Daily we use it between the Malayalam words we put English words. It's like it has become impure. But literature, that's why to have pure language, we study old documents. But in science, we study new things. What is the new discovery? Then growth hormone is not really a growth hormone. It does a lot of non-canonical functions. Our ancestors, 120 years ago, they discovered that when you remove iron, the baby is not growing full. That's why we call it the growth hormone. Now, growth hormone has a lot of functions. Let us see those functions. Okay. Next, please. Okay. See, ancestrally, bone growth, liver, adipose tissue, muscle. These are the function targets of the growth hormone. But recently, it has also has cytokine function, like cell signaling and differentiation function, where heart, cardiomyocytes, neurons, podocytes in the kidney, memory cells are interesting. I want to tell you something. People, lot of people say growth hormone secreted by anti-pituitary. No, growth hormone is also secreted by memory tissues. One of the cancer that's caused by growth hormone, memory cancer, is also caused by the autocrine growth hormone. Autocrine means secreted in the memory gland. Okay, interesting. In the UK, what they did, they gave the injection for children to grow height. Suppose babies sometimes born with orphans, right? When they're growing, what the mothers will see, their kid is not growing as other kids of same. They thought that they can give growth hormone. People, Pfizer company discovered a purified growth hormone, and they will give injection. But the children, after puberty, 16 years age, they give injection, they catch the height. Okay, they become 5'9", 5'10" like that. But when they become 25, 26 years, they got intestinal polyps, a cancer kind of. So nature has a limitation for everything. After puberty, growth hormone should be very basic secretion. Getting point? We need growth hormone for the growth. But once becomes puberty, once our somatic plates are completed, our joints are fused, we don't need growth hormone that much. Only basal level. Same with transition factors. So excess is dangerous. Okay, next slide please. Okay, yeah. We discovered actually as I said, my postdoc we discovered the growth hormone receptor in cardiomyocytes, in macrophages, and also in podocytes. This is their discovery. Okay, till that point of time, I never was in the lab. Okay, I joined in this lab in 2008, something July. That's why I did one postdoc. I completed my PhD in 2007 and 2008. I 7 itself without PhD completion. I joined the University of California. Then in 2008, after getting PhD award, I moved to the University of Michigan. So this lab is very popular. Okay, we are the first people continue to study non-canonical function of growth hormone in the diabetic nephropathy. Next, please. Okay, man. See, I came to India unbiasedly. I want to start my lab, right? So I wanted to start my lab. So this is actually we did a what do you call a microarray. Those days RNA sequencing was not that famous. Okay, microarray. And this is the human patient, sir. Okay, I want to tell you something. Lot of people across the globe they are doing research. First, you big scholars, you should know what is there in the literature first. Okay, take some time. See, you do not know about a software, you do not know about a lab or research. It does not mean that you start again. Okay, you don't waste your time. First of all, give enough time for literature search. Okay, so there are a lot of databases are there. Okay, if you look for retina database or look for kidney, if at all anybody is working on kidney, there is something called KPMP. Okay, KPMP, Kidney Precision Medicine Project, KPMP, and also NephroSeq, NEPHROSeq. Okay, same way we work on cancer. There is a Oncomine. Okay, people are see. Alright, anybody do science in across the globe, they take taxpayers' money. Okay, we do health. Health of an American is equal to health of a Indian. Health of an African is equal to health of a British guy. Any country does work on humans, you can have access to it. Okay, there is softwares are there, the database are there, so many things are there. Okay, so I said something called kpmp.org, NephroSeq, Oncomine. So you based upon your research, lot of things are there. You can test hypothesis there. Right? So not a chat GPT. It's the data done by like scientists like us. A lot of data is there. So I took the data from non-diabetic kidney and diabetic nephropathy kidney. They have data. So what I did was I mined the data. I asked the question to them. I did like you do give prompts, chat GPT prompt, right? You ask so many questions. Finally, you get whatever you wanted. Same way we do a lot of analysis with the database. So this is database I did. See, Nana, this is heterogeneity. Okay. What is heterogeneity? We all are different. Though we live in the same community, though we live next to each other's house, Suppose she got cold, I don't get the cold. Okay, I get the cold, madam won't get the cold. Okay, suppose for example, so in my house I have a sister and brother. I may get an infection, they don't get it. So heterogeneity is there. Among the diabetic nephropathy people, you see notch signaling. Notch means it's a signal receptor. JAG1 like this ligand and H1 is downstream target of the notch. I'll come to that stage. See, a lot of people have low expression, but 1, 2, 3, 4, 5, 6 people have a high expression amongst 21 people. 21, 6 divided by 21 is coming around 25%. 25% of the people, see the number is, everything is the numbers. 25% of diabetic people have diabetic nephropathy. Got it? So now this expression is there in the diabetic kidney. Diabetic kidney, 25% people are expressing more amount of the kidney. You know what? Among diabetic people, 25 to 30 people get a diabetic kidney disease. This is the number. So now these are the podocytes. I went to UK and there's a professor called Boyne Salim. He's of course their ancestors are Indians. He's a very top-notch guy. So I worked in his lab and I got these cells from the podocytes. What are the podocytes? The immortalized cells. They take it from the baby boy and they got these cells from out of their body. He's suffering with this kidney disease. They got podocytes. You can grow them like unlimited. There's a thermosensitive antigen. They make them immortalized. Immortalized means they never die. That's it. You see, like finger-like process you could see. So I did this, took the cells and I did a microarray. You could see here notch 1, notch S1, S2, they are upregulated. Okay, so what I am to say in go to next slide better. Okay, what I mean to say, actually this notch should express very bare minimum in the adult cells. You know, in lot of cancer cells, notch expression goes up. What does it mean? Whenever notch expresses more, cell cycle, cell division, yeah. Array. Students, you are speaking. What I mean to say, a cell becomes cancer cell, notch expression is very high. What does it mean? Notch is a supports cell division. Okay? Notch supports cell division. And cancer cells, lot of cancer cells produce high amount of notch signaling. Okay. In podocytes, which are not cancer cells, the notch expression is very basal. And when we add the diabetic nephropathy patients, notch is more. What does it mean? Notch, see, these cells are terminal differentiated cells. Podocytes are terminal differentiated cells. They are not divided. But when we expose them to growth hormone, when we do the add the growth hormone, what happens to the cells? Notch expression goes up. That's what previous slide. Okay, you see it folks here. This signal sending cell, signal receiving cell. When we add growth hormone, notch expression is very high. Notch has a intracellular domain called NICD. Notch intracellular domain. Notch receptor gets cleaved by one enzyme called gamma secretase. This cleaved after cleavage, this notch, which is there in the surface membrane, it goes into the nucleus, acts as a transcription factor. This is caused the cancer. In cancer, breast cancer or any other cancer. These are not cancer cells, they are epithelial cells in the kidney. We took these podocytes, when we add growth hormone, we measured the activity of the scissor, gamma secretase. Gamma secretase activity goes up with growth hormone treatment. You see notch full length protein upregulated, notch intracellular domain is upregulated, S1 is upregulated, JAG1 is upregulated. What does it mean? When we have growth hormone, notch hyperactive, it causes the cell division. Array, I am not evaluating you. You have to see, science communication, you have to participate in the discussion. I am asking you, right? What all the work I did in the past 12 years, I am trying to put in a capsule for you, like 30 minutes time. You can imagine, you are going to learn the amount of the work done by 6 PhD students. Of course, I gave 10 PhDs, but 6 PhDs work on these concepts. So you are studying in a 30 to 40 minutes time, 6 PhD volumes. Participate, involve. I am telling a simple example. See, he just got here and he told the answer. Notch is a signal is very bare minimum in cells. Notch upregulates, cells will divide. But these podocytes are terminal differentiated, sleeping giants. When we add growth hormone, they cause us cell division, they activate cell division. That's what we observe, right? Yes, got it. And also growth hormone contributes to memory, as I told you. Next slide, please. Okay. Now, seeing is believing now. This is a where there is no growth hormone, these cells are there. This is DAPI staining, the microscope stain. Nucleus stains the nucleus, okay? In no growth hormone, cells are very simple. When you had growth hormone, I stained with the antibody called NICD antibody. NICD means non intracellular domain, which gets cleaved and goes to the nucleus at a transverse factor, okay? It going to the nucleus. You see, I combined both stainings, both the microscope, you can take the overlap image. You could see then in the zoomed condition, you could see in the not both red color and blue color are overlap. So red color is NACD, blue color is DNA. So in the growth hormone treatment, NACD is going to the nucleus. Okay, and they both overlap. Here you could see S1 is downstream gene. The S1 is also produced. That means transcription factor got expressed more, it goes to the nucleus and it's acting on some DNA, its downstream gene also produced. S1 means airy enhancer split 1. It is a name derived from Drosophila, but very powerful oncogene. Oncogene promotes cancer. Okay? When we are talking about diabetes, right? In the diabetes, growth hormone upregulates. And why it is called, it is inducing some signal that is called cancer. See how many diseases are interlinked. Now, to surprise, you people know that next please better. Okay? So we wanted to see what is the connected link between growth hormone and notch. Then the another PhD student completely characterized the growth hormone is notch by TZ beta. Okay, I'm not getting into details of this one because it's a complete story. It takes a lot of time. But what I mean to say, growth hormone induces TZ beta induces notch. This is what they characterize. See how the connection. One student discovered that growth hormone induces notch. Okay, I gave the micro complete characterized. And the student gave it. He told him, of course, growth hormone is inducing notch, but it is via TZ beta. Oh, he showed this one. Okay, so now two molecules are inducing natural. Growth hormone is inducing notch, and whatever the means TZ beta is induced, that's also inducing notch. Got the point? See, I am growth hormone. I act through TZ beta on the notch, but there is some diseases are there where they induce the TZ beta. That is also acting notch. Next slide, please. Okay, this is what I want to show you. This amazing array. In Corona time, we were sleeping in the lab because my house is 26 kilometers from the lab. Okay, and my student, we are just sleeping and eating a 2-minute noodles for 6 months because we got shocked. The shock is that one. These are controlled podocytes now. You could see 3 cells are there. How many people can see 3 cells in the control? Look at there, not at me, boss. Cut the tender. Ferrite in the staining now. DAPI means nucleus. How many nucleus are there? Each cell has one nucleus, right? Cell, one nucleus, cell, one nucleus, cell, one nucleus. Okay. When a cell is resting at the G0 stage, chromosomes are uncondensed. Simple thread like chromatin. We stain tubulin. It is like thread. Thickness, nucleus. See, you could see that. Is a nucleus DAPI. You could see. Beautiful, right? But when we add a growth hormone, see when expose growth hormone, cell become very big, front cell and the back cell also become big. How many nucleus in cell? Huh? How many you can see? 2. What is the chromatin happening? Chromatin become condensed. It become chromosome. Then we start TZ beta. TZ beta further make a big cell. You see cell and the nucleus are connected. Alright, now you tell me. For very long time, people know that neurons, podocytes, pericytes, all are terminally differentiated and they are at G0 stage. And persons, SR1 persons, sleeping, giants. Surprisingly, when we add growth hormone or TZ beta, cells are trying to undergo karyokinesis. That's what's visible, right? This is the first study to show that growth hormone or TZ beta they potentiate a sleeping giant into the cell division. They're pushing into cell division. Okay. It was reviewed by PNAs, but little bit low. Whatever the reason, we are discriminatory. It is just accepted in 2 days in cell death and disease journal. Okay, folks. First, before this study, I said one boy discovered the growth hormone TZ beta. Sorry, growth hormone is not human. So that is published in JBC. Growth hormone induces nothing read. Growth hormone induces notch. Growth hormone teach a bit another paper, full length paper. That time we don't know that this makes the story. That is published in a BBA molecular cell disease. This is work which connects the both of them from this one. So now, if anybody will tell, I have surprise gift for you. If at all I have to show that growth hormone is inducing karyokinesis here, how to show that growth hormone is inducing karyokinesis? I add growth hormone. How to prove again that growth hormone only inducing the karyokinesis? You know karyokinesis nucleotides. Cytokinesis means cytoplasmic. So for a complete cell to become a daughter cell, a cell has to undergo first divide the two nucleus, get the two nucleus, then cut in the burrow, cleavage burrow, two separate cells will separate, right? Fission like fission. Mother cell sacrifice herself to become two daughter cells. But here only two nucleus are getting two nucleus. Okay. So tell me how to prove growth hormone is causing. What you will do if you are a PhD student? So I add inhibitor. Growth hormone downstream inhibitor. I add TGP inhibitor. Yeah, go ahead. Go ahead. Now you see beta. I added TGP receptor blocker. When you add, even the growth hormone is there, when I added TGP receptor blocker, cells are dividing. No. When I added the AG means it's the JAK2, growth hormone JAK2 signal important. That is also prevented. And most important, I use DAPT. DAPT is a chemical drug to block the Notch pathway. No place we have it. So when we use inhibitors, we have successfully prevented the growth hormone or TGF-beta induced karyokinesis in podocytes. You can see all these stages, chromosomes are never condensed. Okay? See, to get this perfect picture. Is it worth for 6 months, right? See, you have to capture, not every cell is divided, be careful, only 30% cells divide. Not every time you get a beautiful picture. So many errors will be there, yes or no? You take so many pictures for you. Suppose you are going for a function or something. You take 20 pictures by your brother or no, by your friend. Finally you pick one picture, yes or no? Perfect picture. Say this is perfect. That's what your friends, everyday sunset. Can you capture sunset, best sunset picture? Out of the luck you get it. Okay, next better. Now we want to show whether really the chromosomes are multiplying or not. Alright, you see growth hormone. And our chromosomes are one set, right? When the cells will divide, you get two sets. Complete dividing and further dividing four sets. Where the growth hormone teacher DNA content is getting doubled, multiplied, and keep on multiplying. Okay, next please. Okay, now this is good. I showed G0 stage, right? They stuck at G0 stage. But to whether they get into our next cell or not, we want to see whether P53 expression, P21 expression. You could see there are some cell checkpoints will be there. I repeat it. Whenever, for example, you know in our South India movies, a hero is traveling in one city to another city. Villain. Okay, for example, I am a villain. Sweeto is hero. Okay, Sweeto is going from Pattaya to Cochin. Okay, now I am a villain, right? I put my first servant, who is a rowdy, somewhere near to the border of Pattaya. Okay, or at the entry of MG or gate, MG gate. Second one I kept it as somewhere second. The bridge is there, na? The bridge there. Third villain I will keep my third deputy. I will keep it near the airport. Okay. So my job is not letting this guy take the flight. Okay, that's I'm villain, right? Now hero what he does? He tried to cross this one. Successfully crossed the MG gate. By whatever intelligence, he crossed the bridge also, which connects that MC road from Pattaya to the MC road. Where is my final villain? Is the strong villain I kept him near airport. He tried to escape these two. What is it? What is the drama in life? He escapes everything. There's no fun, right? Like, movie, you don't like the movie, right? If he escapes easily, then what is the fun? Now my deputy villain has to attack him, right? He escaped at G0 to G1. He can successfully escape the cell division from G1 to S. But my But third checkpoint is there, G to M checkpoint. Let us see checkpoints are activated. Are always you cannot just pass through the cell. Cells will have a mitotic stopwatch. Right? Mitotic stopwatch. There's a clock in my body, right? Now I know time is 11:30. You all waiting to finish the class. Okay? You have to focus here because I came for you people. What if anybody comes out from the room? Don't worry about them. Here is the story. I told the katha is going to finish now. Okay, it's more exciting story. As a Sito is passing through MGU, then MCU road, then airport. Now we captured airport. You cannot escape just like that. There is always a drama should be there in the life. In cell story. So you could shoot G1 phase CDK4. CDK4 is upregulated, still they escaped. S phase marker PCNA upregulated, still he escaped cell division. M phase marker cyclin B1 upregulated. P15 and P21 GTM phase markers are upregulated. Okay, checkpoints are upregulated. Villains are there, but this guy escaped. Completely cell division. But you see, carrier can is happening. There is no cytokinesis. Yes, sir. No, cytokinesis are two cells. Okay. No. Alright. These are my teeth, right? If one teeth becomes two teeth, this one teeth becomes two teeth. What is going to happen to my complete teeth center? Looks ugly, right? Okay. Same way, it's a garland. Podocytes are like garland. One cell becomes two, it will kick. See, for example, you become double now. Once her daughter two cells kick you and kick her, whole architecture is gone, right? So that is why system makes sure that you cannot proliferate. You have to tight control. Okay. But this mitogens, you know what is meaning of mitogen? To promote the cell division, they always with the array, prakriti, nature, try to be normalcy. But in the prakriti also the villains are there. Diabetes also nature. So there lot of mitogens come into the body. Why we get cancer? These molecules like sometimes caffeine, sometimes cigarette nicotine, sometimes rubber with plastic material, sometimes plastic material. These all act as mitogens. They try to induce cell division. Our body don't want cell division. What's happening? They want cell. The mitogens are very dangerous things. That mitogens are that is inducing. That is why my podocytes only undergo nuclear division. It is not letting the cytokinesis. Next slide, please. Okay, that is the why whenever a cell stuck up at a very long time without there is clear division. There is a character is happening. There is no cytokinesis, right? That point of time DNA accumulate, mutations will accumulate. That point mutations will accumulate. So those mutations will notice markers called RAD50, gamma H2, histone, and Q80. These are all very standard markers. Better life is people have done many things wrong, but what we are trying to do, connecting the dots. You know very well that cells are dying. Now new point is cells are trying to divide, but they are completely divide. Okay, next please. Okay, now you see when cells can't divide, obviously they undergo cell death because especially growth hormone TJ beta, PARP is activated. PARP is DNA marker. Cleaved caspase is activated. BAX apoptotic marker. We said the anti-apoptotic. See, anti-apoptotic is decreased selective in growth hormone response. Because this is the facts analysis. You see, alright, control. Q cells are dying. Q3, Q4, more cells are Q4, right? It is Q4. The Q3, Q4 cells are apoptotic cells. More in Q4, that is late apoptosis. See, saying apoptosis is good, but why you went to late apoptosis? So cell trying to survive for some time, but poor guy, internal machinery is very fail. Next beta. So wherever we blocked TJ beta, they are not dividing. Those facts na only selectively TJ beta and growth of the dividing and not other beta. I showed you three cells, three single nuclei. I also showed you big cell with two nucleus. I am also trying to show you this is cascade activation. Right? This is not a cartoon. We analyze it. Okay. Press again beta. So when they stuck up at this stage cell, mighty cell is dying. And also when it is divided, when it is dying, it is trying to see mother cell is dying. It is trying to send its components to nearby cells. At the biology. Cell is dying and trying to send her mitochondria, her organelles to the reproductive cells. See, now we are trying to fresh PhD students are trying to understand what it is sending. Why it is sending? Okay, you know bacteria. If I am a bacteria, you are going to kill me with one antibiotic. I generate that marker. I'm trying to send it to whom? As a bacteria, mother bacteria, I'm trying to send this information to whom? My baby, right? My baby cell. Alright, there is a bacteria, there is people are using antibiotics, try to get resistance. Yes or no? Alright, you being a sweet or you being someone, you use what your trillion cells inside. Okay? So even though every cell is different, but when you're acting like one person sweet or one person cute, yes or no? So every cell thinks individually, but collectively they work. Right? In organ liver, we have so many cells. But the entire organ functions like an organ. Yes or no? Cell to tissue to organ and organism. See, cells are so clever. Cells remember. Cells are saving. Okay. Now I want to ask a question. Yeah.
So I have a question. So you told that when you are at GH, then the podocytes start carrying. What about you didn't show about the inhibitor? You said that you are an inhibitor, then
Oh, you inhibit stop. Yes.
so
Yes.
and just to verify, here, here you said stopping. The checkpoints are
And checkpoints are activated.
activated.
Yeah.
What happened with added? Which checkpoint is stopping?
Oh, there is no inhibitors for checkpoints. Yeah. Suppose you can. Okay. Once you kept me in the cycle, I have to move on. But please sit down there because they can see. See, we use for example, we use inhibitor. For example, I want to tell you. You have TJ beta. I added TJ beta activated. But what I add TJ beta inhibitor SP. You know, TJ beta SP. You could see that growth hormone is there.
Yeah.
TJ beta inhibitors. When inhibitors are there, the checkpoints are not activated. When you have AG is what? JAK2 inhibitor. When you have JAK2 inhibitor growth hormone, these are not activated. And the pathway is not at all activated. They're sleeping.
If your JAK pathway is always active, in fact,
No.
yeah.
Very tiny base layer is active because that's what cell sleeping always tiny leakage will be there. But when we add a stimuli like IL-17, what do you call cytokines, prolactin, or growth hormone, or estrogen, these stats are activated, JAK2 stat. They activate further. Like always a base level will be there. But when you add a signal coming from outside, more pronounced.
Then that
When you use inhibitors, cell cycle is not activated. Did I answer your question? Yeah. Okay. So keep on reading. Keep on next. Yeah. Next. So this is where you are seeing cell death. Okay. That's next, please. We almost done our main story. Okay. Now, don't tell that you never know you do this picture. Okay. I want to tell. We have a lot of freedom now. Scientifically, we're children will be done in 5, 6 minutes. We have a lot of freedom in life as academicians. Okay. The freedom means whenever something idea comes is reasonable, we have to pursue it, right? That see Krishna, okay, there's always uh, sense of pursuing things, okay? You desire to do something. I worked for a very long time with good students, very focused students. So it always bothers me, like from long time. So you know what? When if you can able to see a person, we have cataract. In the center of the lens is a black, normally transparent because cornea is transparent. This iris that's black color. Otherwise, lens are very transparent. So this lens becomes milky cloudy. Okay, in the center you could see dark color. Sometimes in people it is a yellowish color, yellowish dark. That means what? The proteins in the eye lens they become like yellowish. The diabetic people, some people, okay. So the pigments are getting accumulated, and our skin, the diabetic people's skin is little like crossing, right? More. If I am diabetic, you could see little more wrinkles will be there, okay. And HbA1c is also a molecule of adverse glycation. You know, milk, you boil fraction, this is the milk. Okay, you drink this milk more, right? You like this milk, right? Like this color, right? It's naturally you like more brownish, right? We have milk dark chocolates. They all are made of this milk. When you boil the milk, in the milk there are two things are there independently. One is casein. What is the casein? Protein. Caseins will have amino acids like arginine, lysine, histidine, no. So what is unique about this basic amino acids? They have extra amino group. What milk also has the lactose, right? Break down lactose into what? Two molecules of glucose. And what? Two molecules of glucose and two molecules of monosaccharides, glucose and galactose. Glucose. And also we have sugar. You add more sugar, sugar will have fructose also. Glucose plus fructose. All are there in this one. So now what happens when you give energy, heat and all? So what Brownian motion of the molecule increase. These sugars will try to sugars have aldehyde group or keto group, very powerful carboxyl group. And the amino acids are positive amino acids, right? No? They see like, oh my god, beautiful reaction will happen with them. This is called brown color. All our conditions, Maillard reaction. So, you know what is worst part? In our DNA, there are histones are there. Histones will have more amount of basic amino acids. And the sugars what we eat, excess sugars in our body goes into the nucleus and do a lot of modifications. They are called epigenetic modifications. See, this is the consequence of diabetes, beta. If I am your kid, I am your god, I am your brother or son. You know that I need only 20 rupees to go to home to school. If you give me 100 rupees, what I will do excess money? I will buy some nonsense stuff. Okay. If you give excess glucose to a cell, this glucose do all this nonsense stuff. Okay. Formation of AGs, modification of the proteins. It's really happening. I'm not exaggerating. It's happening. Only thing we are correlating with these things. Next, beta. See, this is a meter. You see how much charging. Okay, next please. Yeah, next please. Yeah. So this simple chemical reaction. Don't worry about all these things. I just told amino acids in the reaction with these carboxyl carbohydrates. They form skip space. Amyloid product is accumulate and they act on the cell. Okay. So in your food, whatever, and we eat protein, right? This protein will be degraded by the intestine. Lot of proteins, the enzymes are degraded proteins. So they have AGs, modified amino acids. They act as cell surface receptors called RAGEs. R-A-G-E. R means receptor, AG means advanced glycogen production. Alright, there is something called carboxylmethyl lysine is modified in a proteins called carboxyl. You become carboxymethyl lysine. Carboxymethyl lysine. There's so many amino acids will change. The brown color, what we eat with lot of interest, right? The brown color. They are called methyl glycol. You know, papad, appadam, that beautiful brown color. We will see the very nice golden brown color. Very tasty. It has a methyl glycol. We excess using of the oils, they produce a lot of AGs. They are all there in our body. HbA1c, glycated hemoglobin. See, glycated hemoglobin. That's AG. Okay, they all are formed like this. Okay, I did some studies in this paper. Next paper. So only one slide. We took the glucose. We added the BSA to the glucose and we started producing golden brown color. Thick brown. This is actually what we eat as a candies. Huh? Yeah, browning. Not exaggerating. This is what girls of India eat a lot of chocolates. This is the one. So you could see when we added these compounds, these glycate compounds, you could see notch upregulated. Yes or no? Now I am leaving to imagination. Once notch upregulated, what happened to podocytes? Okay, I don't want to again repeat the story. Okay? Next slide. Now coming to patients now. Healthy patients, kidney patients. In kidney patients glow, see how much amount of NICD, how much amount of JAG has been upregulated. Unfortunate, okay? So this is a urine from the diabetic people. Lot of protein. And this is not urine, that's BSA. To show the albumin. Our blood albumin is there, which is standard. And this is urine, how much amount of the protein is coming, you see. This is a 5 micrograms. How much amount of D. And this is a GFR, kidney function is gone. Okay? Because podocytes got damaged. Okay? So this is the story. Okay? Last story. 2 minutes. Okay. Now, you are talking about diabetes, right? Let's see obesity. Only 1 minute. In obesity people, you could see here there is some gene called WT1, which is also like NACH, transferred upregulated. Selectively. Next slide, please. Okay. Now I want to tell you something. Alright, in the case of obese people, you could see there is a lot of upregulation of WT1. This is a palmitic acid. Podocytes are treated with palmitic acid. Okay, this is also upregulated WT1. Okay, this is a human, mice, and fly. In the fly, you could see the fly has beautiful nephrocytes. Same fly also forms urine. See, when we added high fat diet to the flour, right? I want to tell this thing. Kerala, we eat a lot of coconut, right? Anyhow, whatever the purpose, we eat it vegetable oil because of this geography. We have more coconuts. Our ancestors are very smart to explore the coconut oil and we use for the edible purpose. But we use everywhere this one, right? Now you could see these fly fed with the coconut oil, 14%, 14%. In the this is a normal diet. You could see in the nephrocyte how many nucleus are there? 2. Next slide. Now I took this human WT. I fed diet. Regular diet only 1 nucleus. I fed diet 14% coconut oil, 2 nucleus in this one. WT1 human raw. Right, human WT1 I took from the human gene, kept in a fly, transgenic flies. Okay. Now see WT1 overexpression, 2 nucleus. Multiple nucleus keep coming. See, cells are becoming bulged here. Big cell. Now you could see I removed the.
Is that overexpression?
Yeah. This is overexpression. Now I removed the actually flies WT1 homolar. That is called clumpus. I removed it and I fed it, and there is no binucleation. So I am leaving it to your imagination because I already told the story. What happens when you have more than 1 nuclei in a cell? Okay. So next last slide. Now I kept 3 stories. One story endocrine anabolic, another story diet, third one obesity. Okay, 2 are diabetic models and 1 is obesity models. Individually, anything excess is dangerous, right? Okay, excess bad. Okay, I'm not an exception. Okay, so we always should be conscious. Okay, especially you scholars, take care of your health, your society's health. So what I'm trying to say, in embryonic life, there are some transcription factors, notch and WT1, they will be there. So these will help you to become structure is very good, very beautiful drawing of this could draw. Blood vessels, beautiful podocytes are there. They express very base level of WT1, base level of notch. Now, when you poke with any of the stimuli, WT1 upregulated, notch is upregulated, what happens? Podocytes are detached, podocytes are dying, or WT1 is upregulated, cells become multinucleated, and they are lost. Because of the damage, protein is supposed to be the blood, it is coming out in the urine. Protein comes out, again, whole problem for the body. Immunity will go down, liver will fail. So this is the summary of our lab. We work on transcription factors that are very essential for kidney development. Unfortunately, in disease conditions, they upregulate. Okay? So just a casual observation by children. So my professor Anil observed that children born with type 1 diabetes children have more growth hormone. And they grow up a little bit, they have a negative proteinuria. For very long time, people know that growth hormone, more proteinuria. They can't correct it very long time. When my boss discovered that podocytes express growth hormone receptor, whole story changed. Oh, they have receptor. That means, see, when I have receptor, you can act on me, right? So now my lab, not I, we started exploring. Oh, how excess growth hormone really causes. All of us are there now. Now there is a diamond in this pot missing. What is the guarantee that one of us did, but no guarantee who did it? How we recover it? So we step by step, we have to see that Anil did or Sweeto did or someone did. We have to figure it out. Okay? There is no CC camera. Okay? So the dark, that means cells molecules. We are adding one molecule. What really how happening? How this is door is opening? How someone came? How growth hormone acting receptor? How the pathways? Okay? In the dark, you can't see the molecule. You only can sense the signaling. We are studying step by step. Okay? Now, I am trying to use this technology to treat the cancer. The cancer notch is upregulated. Yes. Now I know growth hormone is using the notch because it is called mitotic catastrophe. The mitosis related cell death is called mitotic catastrophe. Okay, I'm applying this all my knowledge base to whether I can treat the cancer or very weird. So let's be surrounded with people who can discuss the science. Next slide. So this is the last. So I'm surrounded with these people. That guy who actually Rajkishore Mishra, Dr. Mishra, he actually the one who pursued this study. When I said that not just after getting studied the entire study. The other guy, Dhananjay, is in the industry. So this gentleman started working on a W story. This madam, Dr. Sri Vidya Tigrisa, she is the one actually who helped me to get into the field of flight. I can understand. Okay, always be with good people, scientific people. Keep talking science. I'm telling you, at this point of time, it took my God, who had to do it. I want to say, when I look back from my last 12 years to 14 years, when I started this laboratory, I came to India in 2012 January. I came just I came for a conference back to India. I don't have much bank balance. After staying 4 years in America, I just had 2 lakhs. My wife took those 2 lakhs also for buying food. So I just started a creative fellowship to Manmohan government. They paid my return flight ticket here. So then I got a couple of fellowships. Welcome to State is by HST, there's a daily visit. I always wanted to settle in Kerala, so that's why I applied for a job in Thiruvananthapuram. I said I was not offered job, so I went back to Hyderabad where my wife belongs to. I want to settle in some remote area and do some science in Serenity, but I couldn't get a chance. I'm in a very highly populated metropolitan Hyderabad now. Anyhow, so look back now, is it worth it that I spent some time in the lab and I helped people to understand the biology, 10 people got PhD and like 30 students got master dissertation. Look back, it's worth it because I helped a lot of students to become scientists. We try to understand the biology. So we together, students and faculty, we do together we do marvelous things. Uh, don't think that sitting in an MGU in Kottayam can we change the world? Yes, we can change the world. With commitment, we can change the world. First to change, we can change our family, we can change our society, we can change the Kottayam, we can change the Kerala, we can change the South India, we can change the India, we can change the world. So, uh, so that's my story. That's our story. So, okay. Any questions? You asked a brilliant question. Thank you. Um, Please ask questions. Okay. I'm also like you, right? 2002 I joined for PhD. Uh, I completed in 2007. I mean 2002 November I joined. 2007 August I finished it. But I got award next year because I left the country for my job, science. So that's the story in a nutshell. Okay, thanks Chandra madam for having me. It looks very boring, like a lot of time, but I don't know how to say. Even if one slide at least connected to you, I'm very happy. Out of 30, you got 30 slides there. That's 30 slides. 30 slides is equal to 2014. I moved to University of Hyderabad. 2014 to 12 years. 30 slides. Okay. 15 audience. Okay. So what I mean to say is that power in PhD scholar, power of scholars, you never know it. You're very powerful. The passion, the commitment, even day and night you think about your project, right? So imagine when you work hard, how much you can do. It's a new science which is not known by the world. When you do high fat diet, a cell becomes two nuclei. And two nuclei will actually become two cells. It's not becoming cells. So I'm getting into now renal metabolic syndrome, renal cardio syndrome. I'm trying to understand how heart is getting affected by this renal problem. Renal cardio axis. That's called cardiorenal syndrome. CR. Yes, cardiorenal syndrome. That's what we have. We have diabetes, we have hypertension, we have obesity, now we have cardiorenal syndrome, metabolic syndrome, cardiac syndrome. So that's what we use. Complex. Keep studying. Okay. So need of an hour is we have to see that youth of the Kerala has to do exercise, walking, and try to avoid the malpractice in the food industry. Okay, so like condensing our faulty food habits, try to break, try to take good health. So if you start now, you know that in India, the first state to have an literacy, the first district to have 100% literacy is Ernakulam. So same way we start with the first university in India with zero. Let's see, no diabetic cases, MG. Why can't you do? Just it's word of mouth, right? Yes or no? You want to we marry a husband with diabetes. Huh? Say the chance that your progeny will lose that. Yes or no? Yes or no? What you are see, so like you are all adults, right? 18 plus. I'm not talking anything obviously, just I'm talking about the pandemic that is going through the world. And across the globe, imagine at one point of time, the men are becoming diabetic. Obviously, progeny will be diabetic. The gene is transferred, right? You have boys or girls. We never know crossing over occurs. The gene will be there in your girl baby or boy baby, right? So atavism. So we have to be careful. Okay. Yeah. Thank you. Any question? Yeah. Or have a question for me? No question.
This mitochondrial dynamics, the connection which we can connect with what is mitochondrial dynamics.
Whole mitochondria.
Dynamics.
Yeah, yeah.
How is it in
What is mitochondria? Whole mitochondria.
dynamics?
Yeah. So when we have growth hormone, more mitochondria coming towards nucleus. Yeah. So how do you know that I work? You do know I work on mitochondria? Oh my God, you are coming there. Wow. In this context I cannot tell, but mitochondria in this thing, they're actually they fail to undergo crisis like in growth hormone treatment. Mitochondria should be like entire cell, but in the growth hormone treatment, we add growth hormone, they more are coming towards nucleus. So they're going towards their mother. That means they feel crisis. There is a failure of mitochondria biogenesis. And mitochondria does oxidative phosphorylation, right? We measure the activity of mitochondria. Oxidative phosphorylation is compromising them. That is, glycolysis happily happening. Energy production by the TCA cycle is getting reduced. So we're not in a position completely. This which confidence I cannot. We're still understanding more statistical power. There's a girl called Sumati Raviraj, Tamil girl, PhD. Yeah, maybe it takes 1 year, so I can come. Okay, call me next year. I'll come and tell you.
Okay.
Good, very, very good question. Very good answer. See, this is what. See, it's not matter when he came. Grasped it. Okay, so you may be thinking that, but you never know where you will tackle it tomorrow. So we're going to change the course of research. Fine. Okay. Is worth you people spend some time here? Huh? Yeah, please.
Is there any connection between strong basis and analysis fatty liver? Strong basis and fatty liver.
Of course, come on. There are. Okay, I'll put this way. Fatty liver is okay. Liver gets bad really last stage, but kidney can go bad very early stage. Okay. Fat. There's association with the same time. It's called heat hypothesis. So the moment your kidney deterioration occurs, liver started hyperreacting. This is adds fuel to the fire. So liver senses that one. So they're connected, but strong link we have to explore it. They're connected actually. So kidney fibrosis and kidney failure and liver fibrosis are connected. Yeah. And one more thing about the people who already have a liver fibrosis, they have a proteinuria already. Yeah. Yeah. So percentage varies too. Otherwise, the pathways are connected. Fibrosis is also connected. What? In the ANR project, people have a major project with fatty liver. Yeah. So what I would like to tell, uh, go for a strong, uh, 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 like your medical center where you are doing. So we'll see all the patients, different age groups. Try to take the different age groups and see that association. See that we publish that. For tell the Kerala people, public means tell Kerala population, what is the percentage of the actually in the Kerala population between the age of 20 2 to like 52? We'll segregate them, and each what is the odd ratio, like how much percentage they have it. What do we have to do? Like, is it consumption of um, like food versus body weight versus so we'll tell them that please take care of your health. See, after all, health is a fundamental thing for the mankind. So fat liver is very, and it's also with if you don't do any exercise, also fat liver can keep coming. Okay, yeah, body weight should be very prominent. Body weight, body fat inside the body. Non-alcoholic fat liver disease. To try to segregate that one. Non-alcoholic and alcoholic. Yeah. Unfortunately, in southern states, alcohol consumption is very high. Any question? You have to ask one question. Everyone. Okay. So, thank you. Thank you so much for your attention. Yeah, take care. So, not only part of inner pain, in general also, uh, this is an opportunity for us to do little with more enthusiasm. But otherwise also, there are some foundations are there. Suppose you people, when you wanted to do, first of all, the try to take problem from the population. We work for the people, right? The population, see the population problem. And also, I wanted to see that this palmitic acid is dangerous in our diet. In obese people, the palmitic acid levels are very high. Okay, so I want to check the coconut oil. Okay, what is the percentage of palmitic acid in coconut oil? Okay, then I will see that I will give the coconut oil to the rat. Then I make them obese. Let me take some time. I'm not changing the course of the. If fortunately, unfortunately, we don't have much of the oil heterogeneity in Kerala. Kerala, majority of the oil is coconut oil. So, do you eat any other oil in the home for the edible purpose? Sunflower oil. There are vegetable oil is there. Okay, flaxseed oil, rice bran oil. So, I'll see the combination. I take all oils and combination of oils. In combination, suppose 100 ml oil with combination of 10 ml from each or 20 ml from each, I see palmitic acid. So this palmitic acid is in the patient obese, palmitic acid levels are very high. But in natural oils, what is the percentage? Got the point. So what I am the one based upon what I eat. What I eat, I will become same thing, right? Got the point, like whatever the diet. If I always take this gentleman in Hyderabad, he drinks tea. This is a true story, madam. So he gets tea from the tea vendor in a plastic bag. You know the plastic bags? From last 8 years, he has been drinking morning, afternoon, evening. The tea carried in the transparent plastic bag. The boy goes to the shop and brings him hot tea. He drinks every day. He's not feeling well and he went to the day hospital. He got intestinal cancer. So we can't say it's plastic causal, but we already know that plastic is one of them. He's drinking coffee, hot coffee, in the plastics. So a biologist trying to save life. A chemist want to modernize life. Who discovered plastic? A chemist. Who has to treat the disease? A biologist. They always say tug of war. So we have to. And so this plastic, we made it for convenience, but this guy plastic try to avoid this as much as possible, because when it is transported from the source of synthesis to delivery, how much sunlight might have been exposed. So these are the things you never know. And I want to tell last few words. Every cell in our body want to divide except those derivative cells. And every second, out of these trillion cells in our body, one or other mutations are happening, and our body's system is so stronger, it is killing those bad cells. That's actually every time bad cells are forming, our immune system is destroying them, or our cell cycle machine is destroying the bad cells. But unfortunately, one cell will survive. You know what is the purpose of the cell? It wants to survive. It escapes the body's surveillance. These cells are everything. Once the cell survives, it never wants to die. Try to divide its own cells. That is called tumor. See, we have 1,000 police here to catch the bad guy. When one bad guy survives, we try to make millions of bad guys. That is the story of the body. Huh? Kuruchiru Kata. Okay? Huh?
Thank you.
I don't want to bore you.
Thank you so much, sir, for the very insightful and interesting talk. You traveled all the way from Hyderabad to give us this beautiful talk. Thank you so much, sir.
Yeah, the joy of asking. If someone asks more questions, then I used to like it. What do you call? It makes matter. You're not asking questions, This is what the journey is at the end, It's not whether I have answer or not. I'm not worried whether I can have answer for all your questions. But my job is to give you that impulse so that you ask a question. I'm not a great scientist, but am I successful to stimulate that question in you? That's my priority. You came prepared. That's what most beauty of that. That's what. See, out of you, one cell survived. That cell has to grow. Yeah, thanks, Ma. Thank you so much. Thank you, madam. This all.
Say the then say please not say children sir and we said to the
Thank you, Ram. Thanks for your attention. Huh?
ക്ലാസ്സിൻ്റെ ഇടയിലുള്ളതാ കട്ടാക്കിയത്